All right, relatively straightforward question, but it's a little bit confusing. We did it in class, but go ahead, stop the video, read it, see if you can figure it out. All right, they tell you the function b of t gives the temperature in degrees Celsius of a pan of brownies. I guess B stands for brownies. By time. So I guess at different times you have different temperatures. Okay. And then they ask you the question, what does this mean? That's an integral from 0 to 6 of b prime t dt. They say that equals 93. What does that mean? Pause. And again, just take a moment, think it through. Okay. It's not uncommon to have questions like this on the exam. And as simple as it is, it's not uncommon to find yourself confused, maybe confused a lot. I'm not sure it helps to read through the various answer choices. I think they can be a real distraction. I think the better approach is to stop and just think about conceptually what is this. And I'm going to refer you back to, a couple of my favorite phrases or sentences. Okay, area under a rate function equals net change, and the start plus the change equals the end. Okay, these two phrases or concepts come back into play again and again and again. A rate function, well, the most common one when we first do is, velocity is a rate function. It's a rate of change of position, miles per hour. It's a rate function, right? And it gives you the rate of change of your position. But, it's not just velocity. Any function, any derivative is a rate function. In this case, b prime is the derivative of the temp. B is the temperature. I mean, you plug in a time and it'll tell you this thing's going to be 90 degrees or 100 degrees or whatever at any given time. Well, how much does that temperature change over time? Well, that's the derivative of B. This is a rate function, okay? And just like if you're going 60 miles an hour over 3 hours, the integral of 60 is 60t, and from 0 to 3, it's 180. The area under that constant 60 miles an hour over 3 hours is 180. And the area under that rate function is the net change in position. Same thing here. This is a rate function. This is an integral. And they're telling you that the area under this over the period 0 to 6, in this case 6 minutes, is 93. What does that mean? Well, the area under a rate function, this is the area, this is the rate function, equals the net change. Something changed by 93. Well, what's this a rate of? It's a rate of change of the temperature. Well, then the change must have been 93 degrees of the temperature. Simple as that. And which one of these? The temperature of the brownies increased by 93 degrees in the first 6 minutes. That's it. Okay. And your first reaction will be confusion. Reading this thing sometimes will deepen your confusion. Once you think through the basic concept of what is an integral, especially when you take an integral of a function known to be a rate function, it falls into place easily. Okay, now, this is a variation on that. We take the same function, 0 to 6, the integral 0 to 6 of b prime t dt equals 15.5. But I've added this. I'm multiplying this integral expression by 1 over 6 minus 0. Okay? And it's still the same thing, 0 to 6. 0 to 6 of b of t dt. All right? I probably should put the parentheses on this, but it's still the same thing. All right? So what does this mean? Well, again, what did this mean? This was the area under the rate function. And without this, remember it equaled 93? So that meant that the function, the temperature of the brownies changed by 93 degrees in 6 minutes. Well, what does it mean to put this in front? Well, I'm dividing this by 6. Well, if the temperature changed 93 degrees, and it took 6 minutes to do it, dividing 93 by 6 gives you 15 and a half. This is what? The average, right? So if the temperature changed by 93, the average temperature change is 15 and a half degrees per minute. So 93 degree change over 6 minutes means an average change of 15.5 degrees, okay? That's it.